Okay, so before the break, we were going over the general course policies and sort of an overview of what the semester is going to be like, which is pretty much going to be making games and how we approach that. So we're going to be working with Unity, an immensely popular game engine, and we'll be working in a programming language called C#. So I'm going to go through the whole thing. That's a popular language. I assume everybody's heard of it. So back in the early 1970s, there was a project going on, and they needed some new stuff to write an operating system for a machine. And it was replacing a language called, well, when scientists name things, they don't really name things, right? Like the famous water displacement substance number 40 that didn't quite make the Apollo mission. WD-62 made the Apollo mission because WD-40 conducts electricity. But that's how scientists name things, right? So these particular ones have been working with a language called B, because it was their second overall arching one to figure out how to put together new operating systems on Unix machines. And whatever version number it was, I don't know which version number it was off the top of my head, but obviously the next complete overhaul to the point it was a new language got named C. Version 1 release version 1 release 0, right? I think everybody's seen those 3-digit numbers, the version, package, release numbers. So that was just the next one after they moved on from B. And when they were putting that together, they asked a question. Hopefully at this point in your programming careers, you're all familiar with that, right? And when you want to do something new, that's what you should try first. Instead of running over to Google and asking how to do it, they think about it and they say, will this work? And give it a try. Because a lot of times it will. And that's how we learn new stuff, by asking, hey, I wonder if this will work, and giving it a try and refining it. So when they were doing that here, they asked the question, they were putting this together to write an operating system. And on the previous ones, like B, they had explicitly said what machine and system they were writing. And they asked the question, what if we don't say what operating system we're writing on? What we ended up with then, from the answer to that question, is a language with unrestricted access to any machine we write a program for, which is exactly what we want when we're programming, right? So over the years that evolved, then object-oriented programming, which we're going to talk about before long. So I'm going to go on the assumption that in a class number 248, everybody has at least seen some object-oriented programming. By about the mid-80s, machines could handle that overhead. Object-oriented is much better for the human, bad for the machine, but the programmer can do 1,000 times more with the 10% loss in efficiency, so it's definitely worth the trade-off. And we got a very popular language called C++, just the increment the C language. So still scientists naming things, so we don't really get creative names. This gave us unrestricted access to any machine we ran it on. Completely unrestricted. If you were about to run code that would completely destroy your machine, it would just run. So the early 90s, this had grown into an unwieldy monster, and people decided to clean it up for a big project. It was the first attempt at smart TV projects is what it ultimately was. They had a different name for it at the time, but but when we look at the characteristics, we would think, oh, that's they were trying to make a smart TV in 1991. But C++, everybody just did their own thing without restrictions, full access to every machine they were on. It had grown into an unwieldy monster. So the first thing they had to do was clean it up. When they did that, they added some conventions and some other things, and that developed into this language Java, which was in some senses was somewhat restricted we still have full power. So Java is just cleaned up C++ running on a virtual machine. We still have full access and everything, but I always like to describe it as Java didn't take away abilities we had with C++. Java added in warning messages so that we couldn't destroy the machine we were going to run that code on without at least ignoring a warning message telling us we were about to destroy a machine if we hit run on that code. So they cleaned it up, set up some conventions and stuff. Years progressed, that became the most popular programming language. Things change over time, and then it was ready for another very, very common popular language going back to the early 60s. One that actually had a name was a language called BASIC. And the B here stood for beginner. BASIC was originally created by a college professor because it was so hard to introduce new students to programming in 1962. So he made a language that was easier for beginners to get started in. Things progressed. There was lots and lots of versions of that, and eventually Microsoft, that became their main thing, and they switched that to Visual Basic. Still, that B that originally stood for beginner made that a great way for people to start out in, but it made it a very easy language to work in. It's object-oriented, like C++, really easy to work in. That was what Microsoft did most of their early work in. Things progressed over time. It was time for something new. So Microsoft took these two things, which this Java very, very quickly became the most popular programming language in the world after it was created, which really Java is just cleaned up C++ running on a virtual machine instead of the actual machine, for another layer of security over that unrestricted total access to the machine that C++ would give us. So we have that. So Microsoft looked at those two and combined them into one thing. They took a lot of the ease of use things from Visual Basic, but a lot of that kind of filtered into the background, so we don't see quite everything from there. But in the background, some of the good stuff they had there that was easy to work with, and the idea of cleaning up C++ and develop C#. So proprietary Microsoft language. So it has a lot of advantages of both of these. Primarily in the background from Visual Basic, it runs on the original FAT32, Net32 systems, the Microsoft systems as they've progressed over the years. But it has the advantages of Java in that we can't accidentally destroy our machine without ignoring a warning message, things like that. But it doesn't run on the virtual machine like Java does. It runs on the actual machine like C++ does. So a very good language and a compiled language. It's become quite popular. And when they put Unity together, that's what they chose to, that's the language they chose to use scripting in. So we'll be looking at that. What all languages have you all had? I know, I'm guessing everybody's seen Python, right?
Yeah.
Anderson, yeah. Yeah, we use that a lot. Python is terribly inefficient. Right? I like to refer to that thing we always hear in sci-fi movies, the machines eventually rebel because humans treat them badly. That's what Hollywood says. In real life, people put googly eyes on their toaster and give it a name. But if machines rebel because people treat them badly, it's for us, it's going to refer to all the code we wrote in Python. Because there's a lot of overhead, because everything about Python is to make it easier for the human, easier for the programmer. We pass all the work onto the machine, which was tremendously slower, but once the machines got fast enough that that didn't matter, that pretty much immediately became the most popular language in the world. So to start off with here, before we jump in and look at stuff, so in Python, we went with human readable things, right? When we write an instruction, instruction number 1. And in Python, we jump to the next line and then do our next instruction. Instruction number 2. And that line feed, that's where we separate the instructions in Python. So for C#, our instructions are separated by a symbol for end of instruction. A semicolon means end of instruction. So like y equals x plus 3, end of instruction. Kind of assuming x and y already exist there. So that's one thing adjustment if you're used to Python, you'll want to make is the semicolon means end of instruction. So we have to manually type that in. And in Python, whenever we wanted to block off a section of code, right, for like a while loop, we would put our keywords there, then in that line with a colon, and then everything that got blocked off as part of that loop was indented. And in the C family of languages, like C#, we do that with curly braces. We have an opening curly brace and a closing curly brace to block those off. So that's going to be the biggest changes from Python is the stuff that would be indented. So you were indenting in Python, you connect it together by explicitly putting a start of block, end of block symbol or curly braces around all those instructions that go together. And then the new line, every time we end an instruction, instead of just hitting enter to go to the next line, we actually have to put the symbol that means end of instruction. So that's going to be the biggest changes. Our basic flow of logic will be very similar. The other big change from Python, for those who have seen it before, the C family of languages is strictly typed. It means we have to say what type of data we have, and we have to stick with it. So if we want to store an integer, we have to say we have an integer, call it x. And then at some point later, I'll go ahead and assign that. X is 10. Then at some point later, we'll say x is going to be reassigned to whatever x was divided by 3. End of instruction. So what number will that give us? You don't know what 10 divided by 3 is, right? Well, in Python, the one you're used to, that's going to be 3.33333, right? And just 3s until the computer runs out of bits to write there. But in our C family, in a strictly typed language, we have an integer. And 3.3333333, that's a floating point number. Those are different types of data, so we cannot store a floating point number in a spot set aside for an integer. So this would actually give us 3 as an integer. So we have the integer division. We could force it if we put 0.0 in there. Then we have an integer divided by a floating point number. So a floating point number is involved, so the computer would assume we want a floating point number. But if we have an integer divided by an integer, the result of that would be an integer. So strictly typed things, we have to say what type of data we have, and we have to stick with that type. But that's the first thing I want to look at. I always like to look at this first, because 2 things that guarantee we're going to need in every piece of software we look at. We're going to spend a couple weeks talking about C#, so we'll talk about some more details coming up soon. But I figure you all want to get started. So I like to jump in because we know every program we write is going to need some variables to store the data we're going to work with, and it's going to need output. In our case, the programs we write, we want to output back to whatever's going on when we run the game, right? Not the console in the background or print out a separate file or something. We want it to happen on the thing that shows up when we push run on the game, run and play the game. So it seemed to me that a good way to take care of two birds with one stone, because we also need to study at some point how we do those UI panels for the game. So that if we have an inventory list for a role-playing game, the player can click on buttons and select which ones they want, or loading in a save game and have different options, input output functions like we normally see in a GUI. We need to cover those. So I thought we'd go ahead and do both of them at once and look at a few things here. So that's what I like to do for our first assignment is the introduction discussion board. Instead of writing a paragraph about yourself, you're going to write a small program that introduces you. So for one, it can be simpler than the typical paragraph. It can be a bunch of simple sentences. You refer to yourself in third person over and over again because it's the computer introducing you. So in that case, really, I and me would refer to the computer, not to you. So you can just store your name once and refer to yourself in third person. So let's open up Unity. This is the one we're going to work with this semester. And when you install Unity, we have to install it in a special way. Most of the software that you're working with, you're used to things that are compatible, right? If somebody that works right down the hall from you writes something on their version of Microsoft Word, the newest, latest version, and you have a version of Microsoft Word from 3 years ago, you don't expect there to be any problem when they go to open that file, right? That's not the case with game engines. Game engines are a lot more dynamic than that. The version that we use makes a difference. So there's a big thing called version control. So I have, well, let's look at installs first. So when you go to install it, you'll install the Unity Hub. And then you can install multiple versions of Unity. I have the one I installed in the fall. So 2020.3.3.31 F1 LTS. The LTS stands for long-term support. So that means they feel like they've worked the bugs out of this one. They've decreased the team working on this one and moved most of the people to the newer version. And there's just a couple people because they feel like most of the bugs are have been worked out. So you want to download an LTS version. And if you install the latest version now, it's probably going to be different than mine. So when I go to Graders, it's going to pop up a message about version control because you would have done your homework on a different version than I have currently installed. Along those lines, you don't want to change the version. They're constantly updating it. So like all your software, you're going to get those messages saying, do you want to update? Do you want to update? There's a newer version available. Don't. Say if you created something, say in this version, the one I have here, and then updated to whatever the current version is. So to do this, once you install Unity Hub, then you need a license. So you'll see this button here for installing one. Install a Unity editor, just pick one. Preferably one that has the long-term support on it. So the latest version is a little like, maybe you want to install the latest version. You're always looking for the latest, newest thing. You install this one that's in beta test. And then they do an update. The games that are only halfway developed might not work after that update. Depends on how it got changed. So once you have a version on there, you want to stick with it. And you can install multiple versions. Basically, you're going to choose one, click install. There's older versions. I think there's newer versions than this. 2023.32. Did I have an older one? Okay, yeah, I had 3.31 version 1. So if you install the latest one today, you're in a different version than me. So if I had a game halfway developed and it popped up a message said, do you want to update to 3.32? And I clicked yes. There's a chance that some things in that game could be messed up because it was only halfway along working on the old engine. Which is one other thing about C#, I guess I should mention real quick here. You're used to Python. Python's an interpreted language. That means we read instruction by instruction. We write a file of instructions. Then the interpreter looks through there, grabs the first instruction, translates that into bytecode and assembly language and stuff the machine understands, and runs that. Then it comes back, you grabs the second instruction, translates that into bytecode and assembly language, runs machine language, runs that. And the third line, and does it one line at a time. If there's a block, a bunch of indented stuff, it grabs all of those, it tries to compile those so it can use them. But C# is a compiled language. So instead of grabbing things one line at a time, I'll do this picture. Instead of line by line by line, as in an interpreted language, it grabs that entire file and translates the entire program, the entire thing into machine language. That's what a compiler does. It goes through and makes an entire new file of machine language instructions out of our text file all at once. One big advantage of that is order doesn't matter, because it has the whole file there. It can jump around, go to different things. We can mix the order of our functions. We can ask for a function above the line where we actually create the function. There's a lot of advantages. It's quicker. Also, it's way quicker. So usually that's something we want in games, but it's a compiled language. So we will need a compiler, and Unity has a compiler in it. So whenever you go to install one, you'll choose your version, click install, and it's going to try to recommend Visual Studio. You can download that. Personally, I would recommend just a simple text editor, whatever your regular text editor is. I refer to Visual Studio as a text editor, and I avoid the 1.5 gigabyte text editors. The full version of Visual Studio is 15 gigabytes. So it's like a 15 gigabyte text editor. I'm just going to be using probably Atom, but whatever text editor you're most familiar with, Notepad++, Sublime, Text Wrangler, even regular Notepad would work. Anything that can write Unicode text, because that's how we write our programs. We write stuff in Unicode text, and then that gets turned into the compiled machine language code, or bytecode in the case of C#. So go choose an installation of that, and it does take a minute. So you have to do that, and then you'll also need a license. You can get a free license for personal and academic usage. So make sure you grab one of the free licenses for now. When you're out there making in the world making really good software developer money, remember things like licensing fees. Those are write-offs come tax season. And when you're making really good software developer money, you're going to want those write-offs at tax season. But for us, make sure you grab one of the free licenses and choose a version of Unity. Install that. It'll take a minute. You use the hub, and you can install more than one version. You can have multiple versions installed, because we don't want to switch which version we're using midway through a game. And look for the LTS. That's the long-term support. Here in the hub, you'll see there's this Learn tab. So there's tutorials right here, but they're Unity tutorials. They're about how to use the engine. We're going to cover some of that. And in the class here, we're going to be looking more at game development in general, the mindset we need to be in, how to progress stuff, more than just the tool that we're going to use. Unity is just the tool we're going to use. But once it gets installed, we want to create a new project. So you just click on New Project, choose the starting point. All of this stuff can be controlled. You can set up the rendering pipelines and everything yourself. 2D or 3D, for our discussion board here, we're just going to look at the UI panel, the stuff we would use to make a HUD. So 2D will be fine. The 3D game, most of the stuff this semester we'll be looking at those. You can see it's already set up to set it for the VR stuff or the AR stuff. If you have an idea for a game that's going to be augmented reality, you can build it right here in Unity. Unity already has the rendering pipeline and everything set up for it. Some starting points. I'm just going to use one of these first two for our class here. Let's just use the first two so we can study game development, not necessarily Unity. We don't need to focus too much on the tool we're using here. So I'll just do a 2D one and give it a name. I'll call it intro and choose a location for it, which by default is probably going to go into your users folder if you're on a Windows machine. And on a Mac by default, at least on my MacBook, it tries to default to the applications folder. It's a really weird place to put a project. So choose a place to put it. I have this little scratch folder here, so I'll stick it here, call it intro, then hit create project. And it should pull up pretty quick. It takes a little bit longer the very first time, but there's a lot going on here. So we do have to give it a moment. The Zoom call probably slows it down some. Oh, not that much. If you're on a Mac, it's a little bit quicker because of that paged pools in the kernel. For those who have dived in and learned about the deep stuff, the non-paged pools on a Windows machine that make it more efficient. And the reason when Microsoft has the IBM contract and always will, it's better for a machine, but it takes longer for Unity to set up on there because Unity wants to confirm everything's okay. But on a Mac, the first installation's the set, but then everything is stored in the operating system stores everything in human readable form. So it's highly organized and it doesn't get deleted every single time. So after the first try, it opens quicker, but there's not particularly an advantage to one system over another. Well, it should work on all the systems the same. So you'll notice at first glance, there's a lot going on here. We have little panels everywhere. The main menu up top, things about our assets, the objects in our games, components we're working with, what windows we're seeing, and you'll notice that there's even more than are set up here by default. These can be adjusted. You can move this stuff around and grab the console and put the console up here. I wanted to see it there, or maybe stick it over here. There's different setups. Over here on the right, there's some pre-built defaults, some common setups for how we look at things. Widescreen, or I'll just go back to default. I'll just leave it in the default. That's something you're going to click and mess around with this weekend. Is the first thing to do is see if you can find a format that you like to work with. So the basic parts here in our default installation, the default layout, sorry, we have the hierarchy window open. That's the tree showing us everything that's in our scene. So right now, our scene includes a camera. So we'll have to put some more stuff in there. But as we add more stuff, more game objects, backgrounds, audio files, all that stuff, it'll show in our hierarchy. So that's how it shows the connection between everything. In the middle, you'll see there's two panels here, scene and game. So scene is kind of the build mode. The build mode, that's where we move things around, have nice controls, see the grid where things are laying out, do all our adjustments. The game panel is what it looks like when it's running. So as we're putting things together, you can hop over to the game panel. Basically, the game panel is what the camera sees. So I can zoom in and out. The only thing you hear right now is this, the camera. So this white box represents what the camera can see. So we can see way more than the camera, but the game panel here just looks at what the camera can see. So we're doing most of our work here. Then over here on the right, this is one of the main things we want to look at. This is the inspector panel. This tells us everything about the camera. So transform, that comes from linear transformation for anybody who's had linear algebra, because there's a couple things we can do with any object we have in virtual space or real space. There are ways we can transform it, in particular the position. Where is it located at, the X, Y, and Z location of it? How is it rotated? What's the scale of it? Scale it in and out, make it bigger, smaller. That's our transformations on this stuff. Probably don't want to do that on the camera, but different settings for a camera. When we get to that, we're going to look at an easier to use version of the camera. There's a lot of preset things already made. We'll look briefly at some of the controlling that with scripts, but there's a really, really nice pre-made camera we can use that has a lot of stuff. We can see there's all these input boxes here with labels on them. Those are going to be important for us. Down here at the bottom is, well, the console. So error messages, warnings and things like that would spit up here, where we would normally do our simple syntax study, but we only have 8 weeks to study this stuff. So I thought, well, instead of doing that, let's go ahead and put it on the UI panel like we would need in a game for HUDs or inventories and all that stuff we would want in a game. That way we can study those objects and how to connect them while we're learning C# script, and it'll be something more useful than just spitting stuff out to the console. So your error messages and warnings and things will go there. And project is a file explorer. So your normal file explorer. Right now by default, there's an assets folder with a folder called scenes that has a sample scene in it. And if I come over to the regular file explorer, go to where I save this, and y'all probably already know where this is going. Go in here, there's an assets folder with a folder called scenes that has a Unity scene in it. So here's the thing we're building. So it's the file explorer that's restricted to the project we're working on. So all your normal file explorer controls you can use there instead of the default one for your operating system. We'll get to that soon. So first off, we're going to just kind of get started into C#. I just wanted to do enough that y'all can start, clicking around, looking at things this weekend, and intro discussion board seemed like a good way to do that. So we need a text object, something we can write text to so that we can write sentences about ourselves, right? Like in my case, Chris is 43 years old. Chris lives in Clarksville. Chris has 3 goldfish. Those sort of introductions. We need a place to put those sentences, so we need a text object. So over here in the hierarchy, you can right click, and here's stuff we can just create here. There's more than one way to do everything in Unity too. There's multiple options. So right click in the hierarchy, and if we come down here, you'll see UI. That's the user interface panel we need for our game. So there's I'm going to use those words a lot. So from here on out in the semester, if I say UI, I am talking about the component we put into our game. If I say user interface and actually say the whole words out, I'm talking about all of this stuff in Unity, all these different panels and how we control it. So to hopefully help make that distinguish it a little bit easier. So here's the stuff we can add in. So some text boxes, that's the one we need for this evening. Images, buttons, toggles, sliders, scroll bars, drop downs, input fields. A canvas is important overall, an event system. We have to have those for everything. So as soon as we put one in, so for us tonight, we're going to start with the text. And then your programming assignments for module 1 and module 2, where we're covering just C# syntax, you'll basically do this. You'll set up text for output, input boxes, buttons, check boxes, those sort of things to run your stuff. That way it's not going to the console, it's actually relating back to something like a game. So you notice when I selected text, it added a canvas and an event system. Those have to be drawn, and we can, anything else we need, if we need a dozen text objects, they can all go on the same canvas. If we need 3 text objects, 2 buttons, and 4 input boxes, they can all go on one canvas. So we only need 1 canvas and 1 event system, and then all the rest of our stuff just loads in there. So let's look at the canvas. So we saw where our camera is looking. So if we had a background and stuff, we would see that. That'll make more sense in a couple weeks. If I bring my mouse over here and hover over the scene area and hit F, it'll zoom out. It'll zoom focus to what is selected in the hierarchy. So the canvas it zooms out, and it looks like our game scene is really, really small down here, a little bitty thing, and that's just the way Unity set up their thing. So all of our canvas elements, when we put our game together, they're separate. So it looks like our text and our buttons and everything are over on this great big huge panel, but what it is it's a different view. It's made really big so that it doesn't it appears to be something completely separate from our game, because the UI panel just sits on top of our game. If I select the text, you can see it's down here in the corner. You can grab it, drag it around, pick a spot on the screen, and I'll just start by the standard check that we have. Right? The standard check to make sure everything is working. Print hello world on the screen, because if we can get those words to show up, we know everything's connected and set up correctly. And then when we're ready, we can come over here and hit run. And notice it jumped over to the game panel, and the words hello world are showing up on the screen. So we are ready to actually do stuff. Everything's configured and ready to go. So first thing we want to do is study C# syntax, so we know what to do when we write our games. So we need a script to do this. So I'm going to come down here in the assets folder, and organization goes a long way, because the assets we need for a game, they're going to add up very, very quickly. For right now, I'm just going to put the script here at the top level, because that's going to be the only thing we have tonight. So down here in our file explorer, at the top level or anywhere in there, as long as you can find it again, we right click and come up to create. Here's another way to create all the stuff we can add to a Unity game. In particular, a C# script. So we want to add a C# script. What's a good name for this? Well, I'll call it Introscript. Can't think of a good name quick enough. We'll go ahead and give it a name. So we should be ready to edit this. If I double click on this, kind of said this already, the software doesn't know what to open it with. So we have to configure that. I have the Atom text editor installed right here, so I'm going to use Atom. But whatever your preferred text editor is, if you installed Visual Studio with Unity, then it would just automatically open up in Visual Studio. It would be configured to that, but you can change that here the same way. So to set it to Atom, if we go to Edit and Preferences, so up in the main menu, go to Edit, and then come down to Preferences and just set our settings. If you're on a Mac, that's going to be over under the Apple window. where preferences always is in a Mac. If you're on a Mac, I assume you know where the preferences menu is. But on a Windows machine, it's under Edit. On a Mac, it's under the Apple menu, which I think is called the Preferences menu. But however, whenever you get to Preferences, there's a bunch of different things here, some general options, different things about animators. And about halfway down is this option for external tools. And you'll see the top option there is an external script editor. So if you just choose that, you can browse to wherever the text editor that you most prefer is. Which I'm on a new computer, so I'm not 100% sure where the Atom text editor is, but I can probably find it pretty quick. I don't see Atom there. I don't see Atom there. It must be under users somewhere. Oh, there it is. Well, probably quicker if I just Google it. Because I know I went with the default installation. Where does Atom text install on Windows? Well, I was expecting it to tell me where that's located at. I might have to go look for it.
You should be able to, oh, I guess never mind, you already searched for it. I was like, because normally you can just in the search bar.
Oh yeah.
If you just do this PC. Because I kind of forgot where I stuck Sublime at for a second.
Is it searching?
It takes a moment.
Oh yeah, that's why I never used that thing. Maybe I can find it here while the search bar is looking for it. I probably should have prepared for that. Intel. Oh, it's under users. Sorry, I probably should have looked for this beforehand. Oh, there it is. So it looks like Atom installs under users, then app data. So I can find that. Here, under the users folder. You might have to, app data is a normally hidden folder. So if you go in there and under local, there's Atom. And you just point to that exe. And now it should be set so that it'll open with whatever text editor you want. I'm gonna use Atom, but Tyler just mentioned Sublime. Sublime's a really nice text editor. I just keep, lately I've just been using Atom for this. So now when we double click on that, it will open the chosen text editor. Because like normal with programming languages, we're going to write Unicode, something that's symbols we know from our normal written language. I thought it was going to open. Maybe everything's just going really slow. There we go. So double click on it. opened up with the chosen text editor, and you'll see there's some stuff already there. So using is our keyword to import a library. So we're going to use system collections. They expect we're going to need that, and we're going to need the Unity engine library. C# is an object-oriented language, so it's only object-oriented. So everything we do in C# has to be as part of a class. We probably want to access it, so we do have to explicitly say that it's a public class. That way it's accessible. Then we have our curly braces. There's different ways to set them up. By default, it kind of looks like this. White space does not matter. So those curly braces and the semicolons, those all mean something. So the white space doesn't matter. The white space is only for your benefit. They added a couple comments. These are the two things we're going to want every time. We're going to have a method called start. That will run one time when this class or the object based off this class appears on the screen. The start method will run one time. So all the setup stuff there, and then update basically happens every frame of the game. We'll talk about that in detail soon, because saying every frame of the game can be dangerous, right? Because if the computer runs out of time in that frame of the game, there could be a glitch. So when we think about it, we're going to think every frame of the game, but to explicitly do every frame of the game can be a little dangerous. So our curly braces don't matter. We could write this all as one long line, which would probably be almost impossible to read. We want to use white space to make it easier to read. I go with this method on curly braces. We have our keywords to start something. Then the opening curly brace goes on the same line, and the closing curly brace lines up. And then everything in between gets indented to show that it's between those two. And it can be a good idea to label your closing curly braces, because it's really easy to get lost in closing curly braces. So just a quick label there will show what we have. I go with that method. You can use whichever one you want. Some years back, somebody actually took the time to ask thousands of programmers, what's the easiest way to keep track of things with the curly braces? What's the easiest way to read it? And the majority said this: put the opening curly brace on the same line as the keywords, indent everything in between, and put the closing curly brace lined up non-indented. So that's just strictly what the majority of programmers said was the easiest way to read it. Then all our code has to go in between those curly braces. And so we're creating an object called Introscript. And in C#, this stands for inherits from. It's like inherits or the parent object, but it also applies to interfaces and virtual stuff. And it has more than one use. So that's going to get complicated. I'll try to work it in over time. But for the most part, what we'll do is think of the colon as the parent. Our Introscript inherits from mono behavior, which everything we run in Unity needs to inherit from mono behavior, because that's the stuff that the engine works with to apply polymorphism. All of the methods built into the engine work with mono behavior, or set up to accept mono behavior type of data, or explicit generic type data that we will fill in at runtime, fill in when we make our classes. We'll see that stuff soon as we talk about C#, but the parent class, and then we're working on the child class, and everything has to go in between. So first thing we need is some data to work with. So that's what we're going to do for the discussion board, is you'll set up some data points about yourself, and it's strictly typed. So we'll need like string type data. I'll call it name and give it my name. End of instruction. We do have to have that end of instruction everywhere. And see the keyword up here, public. We also need to say whether our data is public or private. Public means other software can access it. For this thing, I think all of our data is going to be handled inside of this class. So we can go ahead and make it all private data. Nobody outside of our object needs access to our data. We can be greedy with it. So we'll create a private string. We're going to call it name and assign it the value Chris. And that gives us something to work with. I'll just put a couple here together. Private integer, call it age, and I'm 43 years old. I don't know, private Boolean. Boolean is sometimes spelled different. I think it's bool here, B-O-O-L for our primitive Boolean type of data, true or false. Going gray. So obviously at age 43, that's going to be a true statement, which y'all have probably encountered this before, right? In Python, it'd be true spelled with a capital T. But notice the text editor didn't notice anything about that. So in C#, our true and false are lowercase letters. That'll be enough for our first sort of, for the example here. You're going to want to put a few more data points about yourself, right? Like what program are you in? When do you graduate? What town do you live in? And basically just store some data points about yourself. But at this point, I assume everybody knows about assigning data values. So here's our syntax in C# for that. Have to state whether it's private or public. If we leave off one of those keywords, it will be assumed to be private, but going with that assumption actually causes a problem in Unity that we will get into next week. Say what type of data we have, give it a reference name, and then assign the value. Oh, and don't forget your end of instruction character, because if you're used to Python, that's an easy one to forget. So now we need a way to put this on our screen. So I'm come back over here, and notice when I came back over here, it's compiling the script. Oh, I got some warnings in the console. These data fields are created, but they're never used. Just a warning, it's yellow, it doesn't matter. We only have to really worry about the red ones. Well, of course it's not used yet, we haven't done anything. Because we want to put it on this text object here, and I'll put a sentence to it. So we need a way to access this text object from our script and tie these things together. So what I'm going to do over here in the inspector panel, see we have all these different things. These are called components. We have a rectangular transform about that. We have a renderer stuff. We have different controls. There's the text one. We'll probably want that. We get down to the bottom and whoops. Get down to the bottom, there's this add component. So we can add it to something new. We can create a new script, or we can search through all the different components. We will see this in detail. We already have our script. So actually, we can just grab our script and drag it right over here. So now notice that now we have this component of that script. Does everybody see that on my screen or on your screen if you're following along? All I did was just grab it and drag it over, or we can click add component and search for it. Whichever way you want. There's more than one way to do everything in Unity. I found it easiest to do the drag and drop, and there's a whole lot of that. So now when our game starts and this text object first appears on here, the text object we see in the hierarchy that all this inspector panel stuff's for, this script is part of it. So this script is going to run. which means this start method is going to run when that text box first appears. So what we need to do is create a reference to that text box, which is in our Unity engine. I think we need to import another one. We'll have to import another library, Unity engine.ui, which is probably what you would have guessed if I told you we needed to import the UI library, right? Did I skip a word there? No, we'll see if I skipped a word there. But Unity has really nice naming conventions like that. So now it knows about other data types, such as a text type of data. We're gonna have a text type of data, call it, well, I'll call it output box equals, it needs something to assign it to. So I don't want to assign it yet, because what I want to assign to this reference, so instead of the assignment, I'm just going to do the end of instruction there and just say that we have that. Because what I want to assign, and I'm going to go back over to Unity without hitting save, because when I hit save, the compiler will run again. And then I have to wait for the compiler. So I'm going to jump back over to Unity. Oh, it did save. Okay, I didn't think it was going to save. But I want to refer to this text box. In particular, I want to refer to the text component on that. So our script is attached to this object. So the script's referring to itself. But one of our components is called text. So we can, one of the methods we will put in most often, usually in the start method, is we can do an assignment. So our output box is going to be assigned method get component, and then we need some angle brackets there, which I'm going to talk about here in just a second. And it's a method, so then we need parentheses, like you're used to from Python, right? If we just have a word, that means store something, that's a variable. If we have a word followed by parentheses, that's a function, that means do something. So we're going to get a component. But these angle brackets here relate to how we're in a strictly typed language. We have to say what type of data we have. In particular, there should be a text component of the thing we're attached to. And I know that word is, I know about that because over here on the UI panel, you see right here in our list of components in the inspector, there is a text component. So we can grab that. And furthermore, all of these things down here, like here where it says text, that's a variable or a data field in this text component. Or here where it says font, we have a box to fill in, but in our script in the backside, we also have that text.font to access that variable, or .font style. So all of these words that we see on the UI panel here in the inspector, those are the data fields we have for our text object. So to access that from our script, we'll say get component, and we need the angle brackets to explicitly say what type of component we're grabbing, and then parentheses because it's a method. So now we have an output box we can do stuff in. In particular, we can concatenate all of those strings into all of this data into a string and output it. So we have our output box. Whoops. Undo that real quick. No, Control Z for undo. So we have our output box, and that output box we just grabbed off the inspector we saw has a text component. And earlier when I wrote hello world in the text component over here, that's what showed up on the screen when we ran it. So that's the data field we want from that component in order to, we want to change what that is. So let's take the name, and then we'll concatenate to that a space is plus the age plus years old. End of instruction. Hopefully I didn't make a typo there. This already took longer than I anticipated it would. That often happens the first time teaching a class, but concatenation should look familiar to everybody, right? Have you seen that programming somewhere before? Plus sign is the concatenation. In all of our C family of languages, we just have the data, so we just export the data, so we don't have to worry about casting per se. The thing that every object inherits from, right? In all our object-oriented languages, there's like that grandparent object that every object inherits from. All of them have a toString method. So there's already a way to turn all of our data. So if we have primitive types like integers and Booleans, there's already a built-in way to turn those into a string. So we can just add them in there. When we make our custom types of data, we do have to make sure and override the toString method so that there's a way to do it. But we'll see that before long. So we're going to get the component, and that's the one we do over and over again. We find the word, the thing we need, the component we need on Unity. We grab that, then we can check that panel for the data fields we want, such as the text data field in this case, and then reassign what's in that. Hopefully all of that sounds familiar from your other programming courses. Kind of makes sense. The syntax is probably looking different. So the compiler ran. I'm getting a couple warnings. These two things aren't used. Hides inherited member object names. Okay, yeah. Name is something we probably shouldn't use, but it'll be fine. Name is something, obviously name is something that shows up internally to the system. So it's gonna hide the default C# version of name and use the name that we wrote instead. That's what that warning's at. I was only expecting one warning there. That's why I had to pause and look at that. But no little red marks to say there was an error. So I run the game and we see that sentence pop up. So that's what the first discussion board is. Write a program that comes over to the UI panel and throws out some sentences about yourself to describe yourself. I think I put some criteria in there. That's not what I meant to click on. I'll go back over to Adam. So I'll go to the end of the line. I have to move the profile pictures. Oh, that might work. I'll move them over there. So I'll add the line feed. I think everybody's seen that before, right? /n for a line feed, /n/r or /r for a carriage return. The old days of typewriters, line feed would just turn the thing to go to the next line. A carriage return would go to the next line and go to the beginning of the line. It's often not an issue with computers because there's nothing on the next line. So when we go to the next line, it automatically goes to the beginning. It's not always the case, but we have the carriage return and line feeds. I'm just going to do a line feed for our class stuff here. And I can add another sentence. Output box.text equals name plus is plus. I'll put that as a sentence. I'll start with the going gray plus, so it'll say true, comma, then my name plus is turning gray in his old age. Might as well go ahead and put a line feed in there. End of instruction. So always remember that end of instruction one. And that's what that first discussion board is. Save some data points about yourself. I put a criteria on there. More is always accepted. So the criteria in the homework is the minimum to do. If you want to do more to get practice, that is always okay in my class. And then output a bunch of sentences about yourself to describe it. No warning, no errors, just a warning. Uh-oh. Why did that not show up? Oh, I must have made a typo because I don't see the whole thing. Or does anybody else have any thoughts on what might have happened?
You overwrote your variable. It ran them both really, really fast.
Yeah. So you're both really close. But when I go back here, how many words fit in our text box? Oh, let me hit F so we zoom in on it. We don't quite have enough room for 2 lines there, right? So we could add another text box or try making this bigger. So I'm on my mouse pad right now, which can be a little odd. You might want to use a regular mouse. That'll make a difference. I brought one in here. So a regular mouse has the middle button, because that middle button, if we click and drag, that pans for us. That does the panning. So that makes a big difference. On the mouse pad, I think it's usually Alt, and Alt drag simulates the middle button. But if we make this bigger, I think it just didn't have enough room to fit. Oh, nope, I must have overridden it. So that wasn't the error. Oh yeah. Good call, whoever said that. That wasn't the typo I meant to make. So we do have our reassignment operators. We'll see that in syntax. So this is usually what I recommend for strings. Get your starting point on the string and then concatenate reassignment. I always call those the reassignment operators. So it's the same as saying output box equals output box.text plus some more stuff. So now it's not overriding the other variable. Overriding the variable, it should be adding to it. But the size does matter. There's an option to make it dynamic. But I think by default, the text box is going to be the size you put it there. There we go. Got a couple sentences that time. And it'll just take a little bit of adjustment, but I thought that would be a good start on how to work with Unity. Make a little program to have the program introduce yourself. And when you're done, when you're ready, just save everything. Right? Our script is already stored in the folder with all those packed with the whole project. You'll come over to documents or wherever you stored it and just zip the folder. Where's zip folder at in Windows 11? I guess I haven't done that yet. Oh, that wasn't selected. There it was. Compressed zip folder. So zip up the project and then send me the whole project. So the very top level, any type of compression is fine. If you got 7-zip or a really nice one, or it doesn't like doing it when stuff's open. Let me try that. So after you're done, save everything, then close your project. Close all the files related to it. Then zip it up and send that. I don't know why I guess I didn't really need to do that. Okay. When Unity is working with a file, such as that text file, the script that was open in more than one place, it's going to label that file as in use, which then makes zipping it, compressing it a problem. But as long as no other software is using it, then you should be able to just zip up that folder and then submit that zipped project. So that's how you're going to turn in all your homework. Hopefully that made sense. Did that make sense? Do y'all see what to do on that first discussion board then? Any questions about that? Did that answer your question, Tyler, about using the text editor? Were you able to get Sublime to work?
Oh yeah, I've enjoyed it. Other than I just have to hit Controls S every time before I load it into Unity, but
Okay,
it's
yes.
okay.
So it won't run it usually won't run the compiler. Mine did. So if that can take time, right? As our scripts get bigger and bigger and bigger, it's going to take that longer to compile. So if you need to jump back and forth, you usually want to wait to hit Control S until you're ready to compile it. But yeah, so that's what the intro discussion board is. And what were the numbers I put on there? 12 data points. So different things about yourself, name, your name's going to show up in every sentences, and 6 grammatically correct sentences. So you'll probably use several data points in each sentence. And there's this picture here that kind of shows the same thing we were doing. Does that make sense to everybody what to do on that? Hopefully that'll get us a good start into working with Unity so we can jump into the more exciting stuff later and learn how to use that UI panel so that when we start putting games together, we already know how to put together a UI panel. We can give our character an inventory list and choose between the bow or the dagger or something. And the normal heads up display. So we have a power bar and our character knows when they're about to run out of health points. So, and play around with it. You'll see there's other options. If I go back in here, will it open quickly? Because obviously this is a big, what? I don't know why I thought it was still running. Yeah, and just zip it, but you'll notice there's a bunch of other options. So all these things about the text, change the font, the alignment, all the normal text stuff, the color of it. And we have other text ones. So your C# stuff, that's kind of what we're doing on C#. Go to UI and add in buttons or sliders. Toggle is a checkbox. So that's true or false, turn it on or off. We'll see those on Monday, get into starting to work with those. So main thing I was wanting to just get started with that starting discussion board, make sure you get the software set up and stuff and get started and kind of, well, if you haven't used Unity before over the weekend, click around on Unity. No, just looking at stuff, right? Click on all your menus and try to get a preview mode, right? Not go through, click every button, but kind of open up the menu and scan through, see where the buttons are so that as we go through the class, you might have a better idea of it. But we're going to spend 8 weeks learning this stuff. So we're going to go into it in detail. Hopefully that makes sense. That's the first assignment. Went over our course policies, our discussion board, first look at Unity. Yeah, and unlike tutorials, well, that was like a Unity tutorial. We just looked at how to use Unity and how to use C#. We're going to get into the key concepts, the frame of mind. That's what's going to separate the class from tutorials you may have seen before. And hopefully it's going to be a really fun class and come together nicely. But that was kind of it for today. Does anybody have any questions before we go ahead and split off? Most of our classes won't run this long. The course policies at the beginning ate up a bunch of our time, made everything go longer because I wanted to make sure we were ready to do something here on day one. I know I was excited about this class. But there is still 12 minutes left in class, so I'm just going to be sitting in here until 8:50 if you have any questions. But otherwise, before stopping the recording, does anybody have any questions to address?
I don't believe I do know.
Okay, yeah, I was getting ready to say, yeah, I started counting down. 5 seconds. It seems like if there's no questions, I guess that'll be it for today. If you have any, let me know. Otherwise, I will see you all on Monday and kind of try to get that discussion board up. And that's the first step of C# and of working with C# and Unity, and kind of look around the interface, get used to it. You all have a great weekend. I will see you on Monday.
Alrighty, I'll see you, Chris.
See you.
Yeah, thanks.